All right, so let's play more with this definition of the definite integral. Big theorem. So integral from a to b f of x dx is area of the n rectangles being added up, and then take the limit as n goes to infinity, so the number of rectangles goes to infinity. All right, so if I'm given this, I see this is the limit of, this is called the Riemann sum. The limit of the Riemann sum is the definite integral. So the limits of the integration, this a and this b, are not in here, right? They're not in here. It has to be given off to the side, like here. So this is the a and this is the b. So I say from pi to 2 pi, that's how we read it, from pi to 2 pi, the integral. And then I'm going to write what the function is. So the function is going to be x sine x dx. And that's it. So dx is equal to delta x, correct? And anywhere there's an x sub I, I'm just replacing it with x. And in that formal definition I gave before, I put the x sub I star. X sub I is fine as well. So I'm not going to carry along the star. All right, same idea here. Pretty straightforward. So I see this is going to be the integral from 1 to 2. This is the limit of the sum. So this is going to be x plus 2 squared dx. Okay, so that's pretty straightforward. It's a little more challenging way to use the writing it as a limit of a sum given the definite integral. So you would have to say the limit as n goes to infinity, the sum, and remember it's I equal 1 to n because I'm adding up the area of n rectangles. So then it's x sub I minus x sub I minus 1 all delta x, and then this 1 and this 10 has to be written on the side to say that's where my a and my b is. All right, one more time. So limit as n goes to infinity, the sum I equal 1 to n, the height of the rectangle will be 3 over 1 plus x sub I times delta x, and again you put the 4 to 6 on the side. All right, I had these earlier, just wanted to remind you of them. So remember, if the function is above the x-axis, then the integral will give you a positive number. Then if the f of x is bigger than the g of x, if f of x is above the g of x, let me make g of x red, so the area under g of x as compared to the area under f of x, because you always go down to the x-axis, the blue area will be larger than the red area. All right, and then this last one here, we're going to be using this in a theorem here shortly. So I just wanted to remind you of it. So that's the function f of x. And then little m is the lowest y value that is reached on the interval a to b. Little m is the lowest y value. And capital M, put it up here, capital M is the largest y value that is reached. Okay, so the exact area under the curve, so this area, red area here, will be larger than the area of this blue rectangle, right, where the m, little m is the height of the lowest y value that is reached. And then capital M is the largest y value that is reached. And there would be that area. So the red area is smaller than the green, and the red area is larger than the blue. All right, we will continue on the next lecture.